Well, I wanted to thank you for taking the time to meet with me regarding OMVAI, and just really honored to have you here. Really, right now you're currently in Seattle, right?
That is correct.
Okay, great. Yeah, is it very cold there?
Yeah, let's see how it is this morning. I think it's like maybe around 10 degrees centigrade or uh, yeah, about 10 degrees centigrade, but eight, not nine.
Okay, yeah, that's great. Yes, Seattle's such a beautiful city, and I do remember you telling me that you've lived in Seattle for almost 30 years now.
Yeah,
So,
Seattle area for about 32
how did
years.
you
Mhm.
Yeah, how did you end up in Seattle, and how did you build up your career there in Microsoft? And I'm pretty sure that it's evolved since then.
Yeah, I graduated from University of Oregon with a master's degree in computer science in December of '89. And I had a job at Microsoft before I graduated. So January 8, 1990, I moved to Seattle area and started my job at Microsoft.
Wow, wow, that's and then how did you start building up your career with Microsoft? What are some of the changes that you've noticed through the years?
Yeah, I mean it's been a long journey, both for myself and for Microsoft and for the industry. Just to set some context, 1990, the software and the computer industry was just starting to take off. I mean, it was nothing like what it is today. Computers were still played a very narrow part in people's lives. And in fact, it really played no part in people's lives. There was no notion of working from home. Having a personal computer was really something that people had at work. And that also very few people, very few industries. So it was the early days. And frankly, I got very lucky to be hired by Microsoft and for Microsoft to emerge as one of the companies which really shaped the direction of computing for the world. So it was the early days. There was lots to be figured out. Everything you were doing was new. Um, and, the first decade, frankly, the 90s was just a decade of exploration, trying new things, see them work, see them scale. There was just tremendous amounts of success. And then, of course, the internet came along and then supercharged everything. And, I was very fortunate to be working on the internet technologies at Microsoft. And, so I found myself in this very unlikely position of being an inventor. Because frankly this opportunity was right there. It was nothing special about me or my genius. It was right there when you're looking at it, and you would go build it, and suddenly you've created something amazing. As you may know, I co-authored the first VPN in the world. And that VPN, in fact, even today, 25 years later, after
Wow.
that news came out, it was one of the most used VPNs in the world. And so it wasn't, again, because I was some amazing brilliant genius. I was happened to be working in the right company, and the right set of factors were happening with the emergence of broadband and the internet taking off. And so these kind of opportunities really existed, and I wasn't unique at Microsoft. I think most of the people who worked at Microsoft in the 90s had a tremendous impact. I worked on the Windows NT operating system right from the first version. And today, if you look at every billions of PCs in the world, they are still running my code. Um, if you look at Azure, large pieces of Azure are still running the same code that we wrote 30 years ago. So it was a magical time. That was the 90s, and then the 2000s was very different. We were seeing computing now pervade people's lives, not just work. Work was starting to get transformed with lives. So people had machine computers at home, and we were seeing the web and becoming the place where everything was moving into, whether that be commerce, whether that be social, news, content, music, movies, were starting to move into the web, and that was an incredible era also of expansion. And then, just towards the end of that decade, mobile became really big, and with the miniaturization of microprocessors, you started to see the mobile world take off, and that again offered new kinds of opportunities. I created the communications business at Microsoft, starting from 2002, 2003, which really grew significantly. What you know as Teams today was something that I started a long time ago. And that was also, again, a period of just tremendous growth and interesting new scenarios coming up. And then, the last decade, this decade of which, we just sort of finished now, the past decade from 2011 to 2020, that is, with the total transformation of how computing is done, where the cloud emerged as something very significant. And instead of us carrying around everything within our computer or on our phone, everything is now being done on the cloud. So amazing transformations. Worked under 3 CEOs, Bill Gates, Steve Ballmer, and Satya Nadella. I've learned tremendously from them, and yeah, so it's been an incredible journey.
Yes, I could imagine that journey. Amazing, and really just thank you for even being that first VP and creating that, and focusing time to and a product like Microsoft Teams, like you had. While you were developing that, I'm sure you had some challenges and while developing those products. Do you sharing?
Yeah, I mean, the good thing about doing something for the first time is that you can do anything. You can try anything. There isn't really any constraint thing that you have to do, and you can build all the parts. And the other good thing is that, frankly, expectations are low when you're starting something new. And the first car, the Ford Model T, was a very simple car, but it was a transformative thing. And so if you happen to find yourself in a place where you are truly creating something new, and the world is sort of transforming in front of you, because of all these factors, the chemistry of factors that are sort of coming together, you become kind of like an artist. And an artist, has a idea in their head, and they manifest that idea without any constraints and with abandon. So it's a very powerful place to be, very powerful place to be. And I was lucky to experience that. Again, luck plays the biggest factor. But you do have to solve unique problems. And for example, for the VPNs, we had to come up with new internet standards. And when you're coming up with new internet standards, you sometimes have to go convince people that, hey, we want to do something totally new. And some of the standards bodies, in fact, the Internet Engineering Task Force, which was the standards body, which frankly gave us all the standards which the internet runs on today. So we had to go there and we had to convince them about, we need to do we're trying to do some new things, and this is what we want to do. And sometimes that was hard to convince them because they didn't have the same vision as us, and they couldn't figure why we are trying to do this. From their perspective, we're coming into mess up this beautiful stack of protocols that they have been working on for a long time. So there were some challenges like that. There were some challenges of technology. We had to extend the technology in many areas, simple things, but, in retrospect, like, they were very important things to get right. When you are doing VPNs, you are basically tunneling a network inside another network. And if you're going to do that, then your network packet is constrained by 1500 bytes. So how do you make the application feel like it is working on as if it has only one network when you're actually stacking two networks, one inside the other network? And that had, brought some interesting, unique challenges that we had to go deal with. I also, I was the general manager of Windows networking when we shipped Wi-Fi for the first time in any operating system, which was in Windows XP in 2001. I mean, that was a tremendously challenging problem technically, because the Wi-Fi standards that we know today, the 802.111b, 802.111a, and all the new standards, they had not been finalized. So you would have chipset from one company and chipset from another company, and they couldn't actually talk to each other over Wi-Fi. The networks are very flaky. The protocols of how the spectrum is used were not designed to be robust. You would start a microwave and your Wi-Fi network would collapse because there was interference happening in the unlicensed band of 2.4 gigahertz and 5 gigahertz. So we had to deal with all of that, because at the end of the day, if somebody started a microwave and the network is not working, they're still trying to use Windows and they're trying to surf the web, and they're trying to figure out, like, why is my network suddenly not working? So in a completely disconnected space, you had to somehow, through the stack, through the operating system, get enough information back to the user so that they realize that this may be a transient issue, or this is how we could avoid it, or even better, to heal the problem automatically by having much more aggressive spectrum navigation technology. There were some amazing innovations that happened at the time, some with now a very close friend and colleague. This company, they invented a chip where Bluetooth and Wi-Fi were both on the same chip. The advantage of which was that Bluetooth, which was also very early at the time, used to use something called frequency hopping, and Wi-Fi used to use spread spectrum. And so you would have a situation where on the same PC, Bluetooth would be interfering with the Wi-Fi on the same PC, and nobody would know, and they say all they would see is bad performance. So this company came up with a chip where they said, we're going to actually, since we know Bluetooth and we know Wi-Fi, we're going to make sure that Bluetooth doesn't interfere with Wi-Fi. And that itself was a transformative thing. Intel ended up buying that company, and now every Wi-Fi chip you see today has that thing built into it. So there were some, lots of challenges depending on the area that I was working on. And then when I got into communications, I was running Skype after the acquisition of Skype and so on. We had to deal with some really amazing technical problems. I mean, the internet was not designed to carry voice and video well. Today, we are having this conversation sitting on two ends of the earth. The amount of technical challenges to be solved to get this experience is mind-boggling over the last 20 years. The human ear is the biology, evolutionary biology, can detect a latency of 100 milliseconds from my mouth to ear. That means that today when I'm talking, and if you're having a conversation with me, from the time the voice left my mouth to when you heard it, everything has to happen within 100 milliseconds. You actually start running into limitations of speed of light. And so how do you deal with that? How do you give a good experience? Same thing with video. I mean, video is you will detect all kinds of artifacts and glitches, and they interfere with the experience. How do you make that to be robust? Some tremendous technical challenges, and many things Microsoft Research helped us with, lots of research in the industry, some research we did ourselves to sort of break through some of these challenges. Yeah, this is a long topic. We can write a book about this.
Yes. No. It's a great discussion, really very productive. I know the technology has changed, like you mentioned, Wi-Fi, using video like now, like and the impact that it's had on people's lives all throughout the world. For example, it's very easy for me to communicate with you now going through interpreter, and then when what does AI look like? How will it evolve?
Yeah.
How does Microsoft into AI?
Yeah, so that's been my, I would say if you take sort of the third decade of my career, really has been about artificial intelligence. So let's, to talk about intelligence, it's good to go back uh, and understand what is intelligence. So, the Earth is 4.6 billion years old. About 500 million years ago, the world looked pretty chaotic. There were just these single cellular, multicellular living things swimming around in water. Um, and then something amazing happened. Suddenly, these creatures became more complex. And scientists have been trying to figure out what happened 500 million years ago. It is called the Cambrian Era. And the fact that things suddenly got more complex is called the Cambrian Acceleration. And what they really saw was the emergence of intelligence in living forms for the first time. So a lot of scientists are speculating on what happened, and there are some theories. But the one leading theory is that somehow through some genetic mutation, these single cellular, multicellular, simple creatures developed a very, very rudimentary ability to see. So because they could see, they were able to find food, they were able to avoid predators, and they were able to be predators. And that resulted in the formation of the visual cortex, which is the part of the brain that perceives what you're seeing. And the visual cortex is maybe the first indication of intelligence in biological form. So what you see today, the sophistication of the human brain has all happened from that moment sometime 500 million years ago to today. That is how biological intelligence has developed. It just, once the visual cortex was there, then there was more and more neurons, and that machinery just kept getting more and more sophisticated. And today we know that it is a super sophisticated machinery. We have worked on, in a petri dish, we take the cells of a mouse, and we are able to make that cells of a mouse, the neurons of a mouse, in a petri dish, we can make it play the game of walk through a maze, to solve a maze, or to play the game of Pong, literally with just putting cells. I mean, that's how the biological intelligence has evolved, right? We've gone to cellular level to be intelligent human beings, intelligent creatures. About 100 years ago, artificial intelligence really started. And I'm saying roughly 100 years ago. It was, famously Alan Turing, who wrote, a lot about artificial intelligence, and basically put forward this test that if you had artificial intelligence, how would you even know that you have artificial intelligence? And that is famously called the Turing test. And then there's been just rapid progress in AI, but in fits and starts. Initial AI, sort of humans approached it that, we're going to approach it very logically and very rationally. So they put rules and so on. And so that sort of sputtered. It didn't go very far. And then you end up with what they call AI winter. And then, the data-driven AI started to emerge. But it was only in the last decade that deep learning, the current wave of AI, really started to establish itself. I happened to be working on AI for about 3 years, just before the deep learning wave came about. And we were seeing data-driven models to start showing a lot of potential, much better than the rules-based AI that existed before. But it still was not great. And it's only when the deep learning stuff came about that we started to see amazing, complex things be solved by AI. Just to give you some examples. Today, speech recognition is which could have helped us in this conversation, and I guess the captioning is probably doing that, is AI-driven speech recognition is beating human experts. Okay, and this is not 5 years ago. This milestone actually was done in Microsoft Research. Okay, computer vision. Again, 4 years ago, ability for a AI model to look at a bunch of objects and to recognize them, to recognize those objects, exceeds human ability. Today, AI models are able to translate between 50 times 50 languages, which is way better than any human being can do. You know, the most people who understand languages may do 6 and 7 and they're experts. This is like 50 languages, right? So performing at a human level or better. So they're just understanding written language is, there are these models, the new models of GPT-3 by OpenAI and Microsoft, which is incredible. I mean, they have embodied the world's knowledge as expressed through language in these very, very deep and complex AI models. So just as the science of AI has advanced so much in the last 10 years, that we are actually calling it the fourth industrial revolution. So if you look at the first industrial revolution, was about mechanical systems. The steam engine basically resulted in all the factories being set up in the late 18th and early 19th century. That gave us the machines. Then the electricity came along, and about 100 years after that, which basically gave us from mechanical systems to electromechanical systems. And that was a huge jump up in productivity and in the world and life around us. The third industrial revolution was computing. That was 1970, 1980, because of the miniaturization of the microprocessor. We are calling AI now the fourth industrial revolution, and it is going to transform everything. Today I know Alexa is very popular everywhere. It's just a small device at home. Everything from self-driving to autonomous factories, flying planes, supply chain optimization, healthcare, FinServe. Anything that you think of is going to be fundamentally transformed by AI. I like to talk about mechanical systems in the first industrial revolution, electromechanical, then programmed, which is the third one when computers came out, and then smart is what happens with AI. And in all these cases, it's not like, the smart systems are going to replace the mechanical systems. At the end of the day, if you're living in a physical world, you have to have actuation in the physical world, but they stack on top of each other. There's a mechanical system, there's an electromechanical system on top, there's a programmable system on top, and then there's AI on top. So the AI becomes the top of the pyramid, which drives just fundamental transformation of these systems. And that is the future. I mean, today, most people lose sense of the idea that the first smartphone was only 15 years ago, 15. It's not even less than that, 2006, when
Right.
Apple shipped the smartphone. And, so the amount of change that can happen in the world quickly is mind-boggling. So imagine that same idea applied to AI, and we roll forward 15 years. It is going to look the world is going to look very, very different than it does today. Anyway, it's a long answer.
No, that's great. I learned so much about AI. AI is, developed so many years ago. I had no idea that it started way back then. I had no idea that that's the way it went. And so when we're talking about AI and the technological changes and machinery, and wow, all the self-driving and self-automated things and planes and machinery, and it sounds a little bit scary at sometimes, but also all of the amazing potential. And so that is really nice to see that. And one day we won't even need the phone. Maybe we'll just click somewhere in the air and it just pops up and here we go. So there may just be a screen right there that that something just sort of pops up, and then we're just chatting with somebody. Maybe they just pop up and disappear in such a short amount of time. And so AI really has the potential to change everything. And it's really nice as far as, maybe like having an interpreter right away and that being able to communicate in such a more ease of a way. And so really with AI, it sounds like there's so many potentials for improvement and change. And so what's the next goal for these 5 years? What does that look like? What would that focus like? What was that focus like for AI moving forward?
Yeah, I think, right now, a lot of the focus on AI is trying to take the advancements in science and to apply them to real world problems. For example, one of the things that my team is working on, I'm leading the autonomous systems work at Microsoft now. And one of the things that, we're working on was we're working with Pepsi. So, everybody knows Pepsi, the company. Some people may know that Pepsi also makes Cheetos, those snacks, which orange snacks, those puffy tube snacks, which, the orange goes on your fingers.
Yes, yeah.
So Pepsi has a manufacturing, of a very sophisticated manufacturing plant which makes Cheetos, but they had arrived at a plateau in terms of productivity and efficiency of that plant, and the plateau was because, given the set of materials which have a lot of variability in them, in this case it's cornmeal is the fundamental material. You add water to it, and then you are basically extruding that through these machines, and the process of extrusion actually cooks the Cheeto and makes it fluffy, and then it comes out the other side with this sort of very puffy texture and so on and so forth. So all that is great, except that they had reached a plateau because with human experts controlling that machine, and with all the variability that was there, they could only get to a certain level of quality production, and they would have waste. Because if they have these cameras which are watching the Cheetos that are coming out, and if they're not meeting the thing, they automatically start, discarding them. And they were dealing with this. And we came along and we built a artificial brain for them, which basically learned from the human experts, but pretty soon started outperforming the human experts in terms of their ability to have much lower waste and higher efficiency. And what is amazing about this is that, these are human factors we're talking about, right? Like some experts are better than other experts. So, the one shift in the day would have very low waste and next shift would have high waste because the people who were controlling it. Now, AI doesn't sleep. AI can work, nonstop. And so we were able to take the metric that they use is 76%. It's an abstract metric. It doesn't map to waste or anything. It is comprised of that, but it's an abstract metric that they have. We were able to take that from 76 to 92, which is, represents such a significant amount of efficiency for them. They have 17 factories around the world making Cheetos, and now the same brain is being deployed across all the factories. Each factory has four machines. So basically, Cheetos is now transformed, and Pepsi is now working with us on 5 other brains that they are building. And the other customers, this one, in fact, the global CEO of Pepsi was so excited about that he tweeted about it last year, about how AI brains are changing how they make Cheetos. So next time you have a Cheeto, just remember that there was AI which made it that look that good.
Oh, definitely. I will definitely remember that. But I was more concerned about how AI would influence people and the work and maybe replace workers. I've noticed, some of them would be replaced, maybe software programmers, computer operators, something like that as far as employment. Do you think it'll impact the human employment for that going forward?
It'll have the way
you talked about like Pepsi, for example. Mm-hmm. So meaning with those factory workers and using that AI brain, does that replace humans and workers with, robots of some kind?
So I think we should expect that there is going to be a transformation in the workforce. And that has been true for every industrial revolution. When the industrial revolution came about, these big machines and, we were making cloth differently. And so that means if you were still on a hand cloth making machine, your job was changed. But there was another kind of a related job which emerged. The same thing happened with electromechanical, the same thing happened with computers. So I think over time, you will see a shift in the kind of work that people do. Okay. Like if you look at construction today, right? And let's go back before the first industrial revolution. Let's say we were building pyramids, They were humans who were taking rocks and pushing them up to build pyramids. Today, if you look at construction and you look at high rises and so on, there are a lot of stuff is happening, which is much more with much more machinery. So the humans are no longer pushing big rocks up these big heights, but they're still doing work. They're doing different work. They're doing planning work. They're doing design work. They're doing coordination work. So every time you have a transformation, there is a shift in the workforce. It's a shift in skill sets, and I think we should expect that to happen here as well. Now, just look at the Pepsi case, right? So you could say, well, are we displacing the experts who were actually controlling the machines? There were few experts controlling the machines. Turns out that Pepsi is not displacing them. They're actually now just making them supervise from afar and intervene if the AI doesn't do something right. So they're actually still using them, but these experts are not in a job where their fatigue is impacting the quality of the product. See, Pepsi didn't need to go and replace the people. They just had higher productivity. So, and that is because, the fatigue, humans are doing repetitive tasks, they get fatigued. I mean, no one can focus on one thing, for kind of a thing. So AI is going to, at least initially for the foreseeable future, is going to take some of these repetitive tasks and automate them. And it is over time, it'll do more and more things, but at that time, the humans will start playing different roles in the process. In the end, optimizing things that the AI is not optimizing. And that is how we see this happening. Today, even just programming, the act of programming is a very cumbersome process. I spent the first 10 years of my career just writing code at Microsoft, and wrote lots and lots and lots of code. And it was, process that was, tiring, repetitive, brain tiring, all those things. Today, we are getting to the point with AI where AI is starting to write code. And in fact, there is a very famous project 6 months ago, OpenAI and Microsoft shipped called Copilot. And it's mind-boggling. You go into your editor and you type in a comment, says, pull out all the data points from this data set in a comment, you write in English, and it produces 1,000 lines of code automatically, which basically does what you asked it to do in English. So the job of programmers, is it going away? Not yet. It's actually making the job of programmers a lot better. I mean, today as humans, we are way better off not pushing big rocks up heights. I don't think I want to do that job, even if that job existed. So it is really just about progression, and I see, that's how we have to look at it. And but you cannot, deny it either. It's better to get ahead of it. In fact, there's a very important history lesson here. When the first industrial revolution happened, these big factories were set up in completely new areas close to where water was there and so on, away from big cities and definitely away from villages, and which created a massive social transformation where people left their families. They were the nuclear families which were living in a multi-generational household. They left that to go work in a factory. And then pretty soon the factory started creating housing. So their wives and children came along, and then schools came about, and, it was a big transformation. But something amazing happened. For about 40 years, there was something called the Engel's pause. Engel was a philosopher. In fact, Karl Marx was influenced by Engel. And it's called the Engel's pause because the economy actually paused. Here, the promise was that economy is going to shoot up because we have these great machines, but it actually paused. It went flat for a while. The reason that happened was because there weren't skilled people to operate these machines. So the transformation that needed to happen from like farming and other agrarian and other type of things into factory workers had not yet happened. So we have to learn from that. and say, okay, if the fourth industrial revolution is going to change jobs, we better skill quickly into jobs where humans can be employed, because over time there will be a transformation in skill sets. Same thing with computing jobs, right? I mean, 30 years ago, there was, I mean, I was the second batch of computer science from BIT Mesra. And, so even degrees didn't exist. And now, computing jobs are just so many. So, that's kind of how I think about it.
Yeah, right. And I completely understand what what you're saying about the artificial intelligence and parallel to here, in today's world now where evolving and changing. And I do support AI as long, so that it will make a potential difference in our lives and making lives better, more efficient, uh, a big change, efficiency for energy, sustainability, for our world too. Climate change, I know, is really such a serious issue. Do you think AI could help with the climate crisis that we're in now?
Absolutely. In many, many ways, actually. So I'll give you one example, which is very sort of tangible. So we decided that we were going to try to control the Microsoft campus climate using AI instead of using the systems that they were using before. And we were able to get like a 20% improvement in efficiency just of energy consumption while maintaining the same comfort level in the buildings. Okay, so that's just one very tangible. So like 20% right off the top of all the energy consumed by Microsoft campus. And now this is something now being rolled out to other buildings and other campuses by companies that manage these buildings. So just a very, very tangible, simple example. But even more so, one of the areas, the hottest area in AI right now is actually how AI is now transforming science. Okay. So the science can be about drug discovery. It can be about new kinds of materials. It can be about new kinds of fertilizers. It can be new kinds of things. For example, if you want to design something that can do carbon capture, it may very well require a completely new kind of an organism that does carbon capture. That is currently being designed by AI, not just by one company. There's tons of companies who are using AI to try and find materials or other things that can actually result in carbon capture, which may be one of the most existential things that we are facing right now. To slow down the global warming. So AI is going to play a very massive role. And then you get into other aspects as well, right? Like, today, if you're going to electric cars and, the optimization of battery use, that is another piece where AI can help significantly. Energy production, it can help much more efficiently. I'll give you one example. So this one is particularly colorful. So, you've seen wind turbines, right? I mean, these are huge, power generating things, and they're literally very, very huge. If somebody's standing on top of a wind turbine, they will look like really, really small. But these wind turbines need to be inspected regularly because they get a lot of shear forces acting on the blades, and they start to break, and then sometimes they get lightning strikes and so on. We've been working with a company to inspect, having to get the drone to become intelligent enough that it can inspect the wind turbine by itself. Now, that shortens the time that the wind turbine is actually not in production. But once we were able to do that, we said, hey, what if we could inspect the wind turbine while it was still running? So we are now attempting to inspect the wind turbine where the drone is trying to fly as fast as the blades. and inspecting the blades while this thing is still working. So, small examples, but show like how much optimization you can do and how much efficiency you can extract out of existing systems. So, that's another example. Same thing with, autonomous operations. They can be hugely time saving. If you could have a completely autonomous factory, you could position it in a place where energy is very easily available, or operating at times that humans don't like to work in. For example, if you go into the polar regions, you don't need to worry about cooling of your data center. You never need to worry about it because it's so cold that your data centers will get cooled just if you pumped in air from outside rather than trying to cool the data center. So, but those areas are sometimes hard for humans to live in. In fact, Microsoft did a very interesting experiment where we put a data center inside a container, and we put that inside the North Sea. We sank it into the North Sea. So this data center is completely lights out. Now, North Sea temperature is pretty, stays pretty low. So they had no cooling cost requirement at all for making the data center work. In fact, they were also experimenting with using wave energy generators, basically turbines, which are generating the power for the data center and no cooling required, all inside this container buried inside the North Sea. So a lot of these things are possible because of AI and the infrastructure that AI can help provide around these sort of things. So I do believe that my personal philosophy is that this nature is an incredible thing, and for every problem that nature creates, it gives us the solution for it too. And that is sort of the yin and yang of this whole creation of ours. And I think AI is a piece of that.
Oh, yeah, I agree completely with you. Thank you so much for sharing some of those examples. Really appreciate it. Over the last 30 years, as you look back on your work, is there something that you might have done different? Thing you might have done differently as you look back over your.
Yeah, there's lots of learnings, and lots of learnings, and I've found that you have to be open to learn and open to reflect, and see where you maybe made the wrong choice. One thing I will say is that it is also very important to be kind to yourself, because we are also human beings growing and evolving with age. Today I'm a very different person than I was 25 years ago. I reflect more, I think more, I have many experiences that I can tap into. 25 years ago, I was a different person. So the way I used to act 25 years ago, sometimes I feel like, I wish I was as wise as I'm now, but that's not real. I did not have those life experiences, and I have a lot of other energies which I may not have right now. I used to work 70, 80 hours a week at work, and it's hard for me to do that now, and so
Wow.
I think you have to contextualize everything with that. Having said that, yes, looking back, just so many learnings, approach on things. There's some things I insisted we do which did not work out, and I can reflect back and say that I should not have insisted on those things. Maybe if I had not insisted as much, I could have seen that they were not going to work out. But I was so, caught up in the energy of the moment and my own, I would say, ill-informed conviction that I pushed through on some of those things which I shouldn't have. There were some other cases also where, I took on some missions that it was very clear they were not going to work out. And somebody had to do them. I don't know if necessarily I should have done them, because nobody wants to work on trying to revive something that is not going to be revived. and feel great about it, because you always feel, God, maybe I could have revived this thing. No, this thing was not going to revive. Maybe I just should not have taken on that mission. So there've been, some reflections like that. Um, I've tried to, based on my own value system, which was informed by my own family's value system and my parents and grandparents, and to try to be a kind, respectful person. And I try hard to do that. And I have to say that one of the biggest regrets in my life are a few moments where I was not that. And they have been, yes, there are always contexts and there are situations and so on. Fortunately, I don't think that has happened too often. But the few times, still over my last 30 years, I regret that. So many regrets, many lessons, but at the same time, try not to beat yourself up too much. Try to move forward, learn from it, recognize that we are, human beings with strengths and weaknesses.
Right. I agree with you completely with what you're saying, is that strengths and weaknesses as humans. Really just can't thank you enough for sharing those reflections over the last 30 years. And there's so much I could learn from you, definitely. You're really just been an inspiration. I know you've kind of, if you were to, let's say, if you were to write a book, what you would want to write about yourself? How would you name it?
This is a great question. I actually think about this a lot myself, and every now and then somebody will suggest writing a book. I have a big problem with a lot of the books that get written. I think they're written with the right intention. Okay. And the problem I have is that so much of the knowledge is contextual, that trying to apply that. So when you read it, you feel, oh yeah, that's great. Yeah, great point. And then you take it and you try to apply it into, situations, and you find that there isn't really a great way to apply it, So at one level, so that is one big challenge. The exception to this is really, when you read books like the Gita, or the Guru Granth, or, they have distilled the wisdom at a level that you can actually apply it in life. So a lot of the books that us mortals write, I find them to be, they're good reading, they're interesting while you're reading them, but you can't really take a lot away and apply it. So let me start by that level of skepticism that I apply to other books, and I would apply to anything that I personally write as well. Okay, so now putting that aside, let's put that whole skepticism aside for a second. What would I write about? I find that the things that really matter sometimes don't get written about enough, because maybe it is how society is, right? Society likes to focus on the shiny objects, and they like to look at the visible success, and they like to look at, wow, how did this person make so much money? And oh, look, they were such a maverick. And, look at Elon Musk doing his craziness that he's doing all the time. And, and so society gravitates towards looking at those kind of things. And frankly, the wisdom is not there. At least wisdom that you can take with you and apply over a period of time in many different situations is rarely there. It's more like pop culture, it's something that is interesting this moment in time and space, and it's not at all interesting a little bit later. So I would talk about those kind of things that matter, that endure, that are not totally tied to tied to the context that they are in. And there are some, like for example, the art of creating products is a very very difficult, very elusive topic. We see great products, we recognize them, and we see the people who created them. There's very few people in the world who I think create great products, very few. But there's many people creating products. It doesn't mean they're great products. What takes in creation of a great product? This is 30 years of reflection and observations and mistakes and trying things myself and occasionally getting that level of greatness on some idea. But I think that is like a very deep sort of a topic. In fact, if you really want to get any wisdom around this, you have to sometimes go and read Japanese wisdom, and you read it, and it is so, nobody wants to read it because it's out there, and but in there are the gems, but they are not part of our our collective knowledge today. I think that is one that I really think about. This whole notion of the fundamental tension between the sort of capitalistic models and innovation is a very complex relationship. And what are some deep wisdoms underlying that? And that these things I've observed myself, and I feel like people go through business schools, and some are working in big companies, and they don't have that what are the real dynamics that are driving some of it. You see I mean, this is there today, but it's not apparent, right? You'll see, why is some VC doing so well? Well, because they have figured out some connections that are not obvious to people, but nobody talks about what those connections are. Why are some big companies able to innovate and others not able to innovate? What is it about their culture? And people have tried many things, and there's entrepreneur and intrapreneurs and books and models, and very, very hard. Like there's a good book on that one, by the way, called Loonshots, Loonshots, which kind of gets into that topic, and what is the chemistry of innovation and how to do that in a big company context. So I think there are some topics like that which I think are I would write about with the skepticism caveat.
Yeah, I definitely am looking forward to reading that book someday, if and when you would be able to write it. The knowledge that you'd be able to share with not just myself, but the rest of the world too. So yeah, really appreciate that. And speaking of AI and products and just the making of products, develop some type of a hologram, maybe like a hologram type of interpreter, right? If you could develop something like that, that would be something amazing for those in the deaf and hard of hearing community throughout the world. I know that would help with accessibility, the school, the government, the workplace. That would be great.
Yeah, I think this stuff is being worked on. Yeah, absolutely. I think this is, in fact, we recently did even in Microsoft Research, and this thing did one big piece of that. Let me just quickly look it up. Yeah, I don't think it's been announced yet, but we're actually working on parts of that already. So basically, I think I may have mentioned it, Weber, when we talked last. So today we talked about AI and translation before. So today at this point, language to language translation we have made so much progress. It is mind-boggling because of advanced AI. So to go from sign language to the written language is just a translation task, except that the input is not words in a different language. It is actually the video stream of the signing. And that is the specific piece that I know that Microsoft scientists and have been working on. And it's a very, like at this point, I don't see that as a hard problem. It is a very solvable problem. So that's one piece of it. That is the recognition. Then there is the synthesis. So how do you actually render it and play it out if you have words and you want to sign it? So that is even an easier problem, because the model which takes language and says you need to do these transformations using some generative methods that exist in spades today. So I think this particular thing, once you render it in 2D, rendering it in 3D with a hologram is just a very, very simple step. So I think all the pieces are there, and somebody needs to put it together and make it usable in different contexts, right? So that sometimes becomes a harder challenge. Like, how would I present it into this conference where, that it would work? So one of my most, I would say, my 1 minute of fame happened in 2015 when I demonstrated the first conversation in which I was speaking English and the other person was speaking German. We demoed this at the Code conference. It was covered around the world. We got 1 billion impressions in 1 week around the world. Everything from Time magazine to everything interviewed me and wrote about it, and CNN had it, and my parents saw me on CNN in India, doing that demo. Because it was so transformative. For the first time, I'm talking English, the other person is talking German, and we're having a conversation. And I think, just to make that scenario work, we had to do so much work to make the experience right inside Skype. Similarly, if you have to make signing natural inside of this environment, it would take a lot of work in getting the user experience right. So to me, it reminds me of that use case. Yeah. But the science is all there. At this point, I don't see any of the pieces of the end-to-end solution to be a hard problem.
Okay. Wow. You're right. That's it's just I'm excited for that new technology to come in and here and just just for that new fame for you someday. Yeah, definitely. Yeah. I wanted to, thank you. I know it's been about an hour of us being able to have this discussion and sharing. I've learned so much, and just thank you for taking the time. Just one last question. If you could, I would say, if you could just describe yourself in one sentence, what could that be?
I'm a curious technologist who wants to further the way we live, the way we work, the way we play on the back of emergent technology.
Oh, that's beautifully well said. Encapsulates your journey both professionally, I would say, and personally. So, thank you. Do you have any other further messages for this talk show that you'd like to add?
The only thing I would say, especially for people who are earlier in their careers and looking to make their life and work and leave an impression on the world, is that the most important thing in the world in the final analysis is to be a good person. And whatever you endeavor to do, endeavor from a place of good intent, whether that be good intent for the person in front of you, whether it be good intent for this society, for this planet. Never lose those things, because the world is full of shiny objects and we will chase all kinds of things, but never lose those things. They are the most fundamental, they are the bedrock of, I would say, a good, wholesome life.
Wonderfully said. I will make sure to keep that in mind. Very, very powerful message. Thank you. Thank you again. And go ahead and stop the recording. Thank you so much for your time. I really appreciate it.
Take care. Bye-bye.
Thank you. Take care.